We're going to do an introduction to logarithms, and I'm going to show you an idea that we created when I was in this special project called Project Seed. It was a special project out of Lawrence Hall of Science, and it has to do with the idea of undoing operations. So for example, let's take the addition operation and the problem 10 plus 15, which we know is 25. We're going to undo this. Because we're dealing with addition, we're going to undo, and the operation to undo this is subtraction. Well, it turns out there are two sentences that would undo the 25. One way is I take the 25 and I subtract 15 and I come up with what's left, which is 10. The other way is I take 25 and I undo it by subtracting, and I subtract 10 and I'm left with the 15. Because 15 in this expression, 10 and 15, is on the right, I'll say that this is undoing this addition problem on the right. Because 10 is on the left, we'll say this is the sentence that undoes it on the left. Following this, if I said 8 plus 7 is 15, we'll just practice undoing this in this new way. So we'll undo the subtraction two ways. Undoing this on the right, it's 15 minus the 7 is on the right, and we come up with the other number, which is 8. On the left, it's 15 minus the 8 is on the left, and we come up with the number 7. We have undone this addition sentence two ways. Now we'll look at the operation of multiplication. 9 times 5 equals 45. I want to undo this multiplication. So we're going to undo this two different ways. And the opposite of multiplying, to undo multiplication, we are going to divide. There are two ways we can write a sentence to undo the 45. We can say 45 divided by 5, and that gives us the other number, 9. Or 45 divided by 9 gives us the 5. Because the 5 is on the right, we'll call this undoing this on the right. Because the 9 is on the left, we'll call this undoing this on the left. Now we're going to look at another operation which I call exponentiation. And with this one, I'm going to look at the problem 2 to the third power equals 8. And we know that's 8 because 2 to the third is 2 times 2 times 2. And 2 times 2, 4 times 2 is 8. I'm going to write this as 2 exponentiation 3 gives me 8. I am going to undo this exponential equation, and we're going to undo it two different ways. If we look at this, and this is just another way of saying 2 to the third, 3 is on the right. So if I'm going to undo this on the right, it's 8. Now I'm not sure yet what the operation is, so I'm going to call it the operation R, undoing that on the right, 8R3, and I get 2 as my answer. If I undo this on the left, it's 8L. I'll put L for that operation. I don't know yet what that is, but I know 2 is on the left, and I get 3 as my answer. So looking at this a little closer, we see when we took 8 and undid it R3, we got 2 as our answer. And we look here and we can see that that answer is the base. But when we say 8 and we undo this on the left too, we get 3 as our answer. And we look and we see we get an answer that's the exponent. So when we're undoing exponentiation, the R function gives us the base. The L function picks off the exponent. So let's look at the first function, which is R. I said 8 R3 gives me 2. So I'm thinking, what can I do to 8 that involves 3 and gives me 2 as an answer? So thinking about this, we know that if we took the cube root of 8, we would get 2. So this can be thought of as cube root, third root of 8, and we know the answer is 2. So R is our cube root function, or in this case R3 cube root. R is the root function. So R is root. Now we look at 8L2 and the answer is 3. And this is a function, to undo it, that you may not have seen before. I have to do something with 8 and 2 and come up with 3 as an answer. And it turns out that L function we're going to call logarithm. And we're going to write it like this. Log of 8, and the base of 2 is down here. So here's the 8 and the 2, and the answer is 3. The answer is the exponent. We'll practice writing the L function as logarithm. If I said 25L5 equals 2, that can be written as log of 25. The base down here is 5, and the answer is 2. What we're going to see is writing it this way with the base down here gives us what we call an equivalent exponential. From this, I get an equivalent exponential. I call it my round robin. And the equivalent exponential, the equivalent equation, is 5 to the 2 equals 25. The logarithm sentence and this exponential are saying the same thing. From this point on, we're now going to just focus on the logarithm because we've done radicals before. So if I say log base A of B is C, this only has meaning if I write the equivalent exponential, which is A to the C equals B. So the way we're going to be able to deal with logarithms is to write this equivalent exponential sentence. So what we're going to do is a few more problems. So for example, suppose I said log base 4 of 64 is x, and you have to find x. The only way I can do any of these logs will be to write the equivalent. So the equivalent is 4 to the x equals 64. And then I need to look at that and see what x is. And this one way of thinking of it, we know that 4 to the x, it turns out 64 is 4 to the third. So x becomes 3. Therefore, that means the log base 4 of 64 is 3. And as I mentioned, the answer you get should have been the exponent of that base. We'll try another one. For example, suppose I say log base x of 49 is 2. The equivalent exponential will help me, and that is x to the second equals 49. Now some people will look at this and say x squared is 49. I know what x is. It's just 7. If it's a problem you don't know, you can just remember when you have x squared, you can undo it by taking the square root of, and the square root of x squared is x, square root of 49 is 7. So that's what you get. And notice that 7 is the base. And so the base goes down there. So another one, let's say I say log base 6 of x is negative 2. We write the equivalent exponential, which is 6 to the negative 2 equals x. So now I have to review that a negative exponent is a reciprocal. So this is 1 over 6 squared is x, and therefore we can see x is 1 over 6 times 6, 136. So that becomes our x. We'll try one other that might be a little bit tricky. Suppose I say log base 3 of 1 over 81 equals x. So now for this one we say 3 to the x is 1 over 81. The trick in doing this is because the base is 3, we have to put 81 with 3. That is powers of 3. So it turns out that 3 to the x is 1 over 81 is 3 to the 4th. But it can't be written that way. It has to be written 3 to the x. 1 over 3 to the 4 is 3 to the negative 4. Then from there you can see x has to be negative 4. So x is negative 4. Because the exponent that gives you 81 over 81 would have been negative 4. So the key in problems like this is to write whatever the base is, you want to write the other number with the same base. One last one is if I say log base 5 of x is log base 25 of x is negative 3 halves. So the base is 25. The equivalent here becomes 25 to the negative 3 halves power equals x. So this will be a good review of our exponents. We know negative means reciprocal, and then we have to remind ourselves what the 3 halves power is. Looking at this, we see the negative. We get 1 over 25 to the 3 halves is x. But now we have to review. We know the half is telling us square root, and the 3 is cubing that. We now can see that this is 1 over the square root of 25 cubed is x. Finishing this, we see x is 1 over square root of 25 is 5. When we cube it is 5 times 5, 25 times 5, 125. So we have that the number in here, this x, was 1 over 125.